November 3, 2025. Hello, welcome to a study of foundations, here reading foundations from Ross Finlayson. Hello, gentle readers, fellow earthlings. Today is more of that there's a giant backlog and stack of books to read through here to kind of gather an apperception of the library that's been sort of built. And then the idea is that there's not really so much time to dwell on each of the works, yet they all form sort of a common thread. So with that said, then my idea, the structure of this is kind of to talk a little bit about reading, the act, and the activity itself, and then just read into these books. So reading is a remarkable concept, a textual, because it's essentially not a matter of the physical senses, while at the same time it's entertained as in terms of how it relates to the physical senses, sight, taste, touch, hearing, smell, say, or the electrical pain, various notions of otherwise whatever would serve as a stimulus. For example, the idea of the extrasensory perception, that reading is in a sense itself a form of extrasensory above these otherwise senses, perception. Then here is that all the phenomenological accounts, as after something like the Epicurean or for Kant or these kinds of things, have to be in terms of the senses to be intersubjective. There's thus that there's modeled in an object sense, a word sense, a time sense, a number sense, and a sense of the continuum as part of the nous, the noumenological, which is otherwise these matters of abstraction and apperception, that as well is, at least on the surface, directly interfaced to the physical senses, and has in its terms, as they may be, is in the terms of the qualities and quantities, the qualia of the senses. So reading books or text is different than watching a movie or otherwise ingesting the media via the senses. So this is, for example, that when a book has a narrative, then what it establishes is not so necessarily for the descriptive according to the senses. It's matters of identity, and it's otherwise relations within this space of the noumenological. So in terms of whether graphical learners and visual learners are as according to relating it to matters of diagram and the pictographic, or otherwise relating it to matters of the textual, and thus separate, apart this way, has that either in both ways. It's sort of either in both ways when reading a text, yet it's not necessarily so just from the experience of sensory input. Stimulus and response, and so here this is kind of that, man is machine, man is animal, and man is mind is the idea then being above that. But it just goes to show that even then in reading, some people have it that it's to refine and define what comes to the senses, but in the abstract it's sort of everything that it is not. And so it's kind of like the suspension of disbelief. To enter a movie theater and check your sense of belief at the door for two reasons. One, to experience the narrative, and another to leave undisturbed, otherwise, what is the belief. And so the suspension of disbelief is the sort of idea that is otherwise that one would not correlate necessarily experiences of the theater with experiences of the mind. So the reading the book is quite so similar that way. It's check your senses at the door. And so in this sense, and when I say that, it's in kind of a figurative sense, say. But yet, it is as well as exactly as to relate that there are these physical, phenomenological senses and mental, noumenological senses. That the idea then that reading is a cerebral experience and an individual experience, and is as well yet part of the phenomenological and also the noumenological, has that at least it entertains, if only at the shallowest layer, the noumenological. And so for the suspension of disbelief and suspension of sense, in a sense. So this is just something made for the, reading is fundamental, and more so, it is an exercise, the ability to transliterate text into narrative. And so that when some people read a book, they're painting mental imagery, or otherwise representing, according to their reading, the fabrication of what would be for the senses. And for others, it's kind of the opposite of that. It's kind of as in a vacuum from that. And so the events so connected, as for the object sense, a word sense, a time sense, a number sense, and a sense of the continuum, then relating those to qualia of the mind and ideas, thoughts, concepts, and so on. This is just making it clear that, for example, in an account here that is kind of a spoken word account of these kinds of ideas, that would be kind of the same as the written word account of these kinds of ideas, has that as well. This is a text. And so for the deconstructive philosophers of the sort about the establishment of narrative and ideas and concepts and thoughts, for that is that this is also an account of that. And so while it is so, then it is not absent otherwise the sensory inputs, as for example a page can surface as text in its typography and font, and even in pictures and diagrams or picture books and this kind of thing. It's also not absent the ideological, and then that being is for the somatic and soma and these kinds of things. So that thusly, that's there's something to be relayed then, that people's interpretations are entirely dissimilar, possibly, compared to, according to a model of rods and cones, the pictures of the eye, or according to a model of pressure and sensation, the sense of touch, or pressure, or pain, or heat, or cold, for examples. Or the idea that taste is sweet, salty, sour, and bitter. The ideas associated with the interpretation and the inner subjectivity of experience without the immersion in experience. So some people have a hard time suspending disbelief, and some people have a hard time not. And some people have a hard time suspending sense, and some people have a hard time not. So encouraging reading basically at least makes it so that it's possible to maintain both of those, because otherwise then it at least be possible to say that one is just subject to being like an ant on his pheromone trail, or what's another sort of example of that? Well, it's yet part of its greater colony and this kind of thing. Or the bee and its hive and the waggle and this sort of thing as it's related. And the magnetic of these creatures. Vis-a-vis, the red dot and following the red dot. Or these kinds of ideas from anthropomorphism, and then it's kind of like animal-omorphism. The idea of the machinery of these kinds of things for our minds. So hopefully that's just sort of an idea that helps relay that. Here it is kind of introduces the suspension of disbelief and the suspension of sense. So it's kind of like entering the movie theater involves suspension of disbelief or sense, and as does the entering a book. So let's enter the books then. Vis-a-vis something like Enter the Dragon, which is a cultural reference that not all will know about. So before getting in the box of books, here's a few loose books then. So these first few loose books are about mathematical constants or related mathematical fundamental formulas as they're deemed to be. So this is Euler's Gem and the story of -1. This Naheen's The Story of -1 is very well written, and it's nicely written, and it's pleasant to read, and so I enjoy that. And then here's this Elie Maor's The Story of E, or Euler's number is called, but it's after Napier. It's the constant of the natural logarithm. So it gets in here, for example, it's talking about squaring the hyperbola, and this will get in a lot of different things because these essential mathematical things are often the limits of other things besides being able to be taken as according to their roots and powers and so on. Those limits in making other analytical ideas. Here it mentions Roger Cotes. Euler, however, was not the first to arrive at this formula. Around 1710, the English mathematician Roger Cotes, who helped Newton edit the second edition of the Principia, stated the formula that log of cosine phi plus I sine phi equals I phi, which is equivalent to Euler's formula. This appeared in Cotes' main work, Harmonia Mensurarum, published posthumously in 1722. Abraham deMoivre. So that's usually framed in terms of deMoivre, and then the Eulerian and Gaussian. But it's nice to point out that Roger Cotes, who's known so much more for numerical methods and for example, Newton's method and these kinds of things, Roger Cotes, and sometimes spelled Coates, and other times Cotes, is one of the better of Newton's lions and giants, Roger Cotes. And here it's just as noted. He made Euler's formula before Euler came up with it. This appeared Cotes' work published in 1722. Abraham deMoivre, 1667 to 1754, whose name is mentioned in the epigraph to this chapter, discovered the famous formula cosine phi plus I sine phi to the n equals cosine n phi plus I sine n phi, which in light of Euler's formula becomes the identity e to the I phi to the n equals e to the I to the n phi. deMoivre was born in France but lived most of his life in London. Like Cotes, he was a member of Newton's Circle and served in the Royal Society Commission that investigated the priority dispute between Newton and Leibniz over the invention of the calculus, or the calculi. If one's to be the integral calculus and the other differential calculus, they can be made differently and variously, vis-a-vis that they come together to make one. So just like energy is ubiquitous yet indistinct, and then later it is similar to these other kinds of things. So this is useful to help just understand where things come from, and also then to understand the different approaches and ideas about what these things would be. So the Eulerian Gaussian is a thing, and it's definitely very, very common, but it's not necessarily indispensable. Florian Cajori. Cajori is mentioned. I just was moving around this Struick's history of mathematics and Boyer's history of mathematics, and so Florian Cajori shows up regularly. It talks about the dimensionality of things. Here there's the dimensional, and then the kind of the fully dimensioned, the infinitely dimensioned in one, or the hologrammatic, or the holodimensional. I guess that's now to be a word. Holodimensional looks like one dimension, however you look at it, or infinitely many, if it's going to be that way. And so at least from one direction that way. So this is then mostly about Euler's number, and so the developments come after that. An alternative definition of the logarithmic function, Appendix 5. So this describes the usual notion of the defining E as the integral from 1 to infinity of dt. So that gets into that there's the natural unit equivalency function, which is just Xenocrates' line drawing, and it's Hilbert's principle of continuity filled out, Leibniz's principle of perfection filled in, the natural unit equivalency function, domain in natural integers, range, unit line segment, It's countable. Continuous domain is, according to people, as maybe pointed out, the quasi-continuous and quasi-algebraic of Dana Scott or Jimmy Lawson. Then as here, as independently, if that's only in the last 20 or 30 years ago, that's kind of pushed up again constructively, because it still, without the rulio foundations and the repleteness, is self-inconsistent, together with the other aspects of mathematics. That the natural equivalency function is a superclassical function, and it's non-standard because it's a discrete function. Its domain is discrete, but it's integrable. But its integral isn't equal to 1/2, as it would look like if you put the discrete parts together. It involves this doubling space and doubling measure, so its integral equals 1, just kind of like Dirac's delta function, the only non-standard function currently everywhere in mathematics for 100+ years, of with 0 or infinitesimal height infinity, area 1. That then this function is and similarly as that as being a distribution, it's a CDF, it's a cumulative distribution function, density, probability density function, or probability mass function. It's quite a few of these many things of the integers at uniform random, as if you could pick a random number from all the numbers, all infinitely many of them. And so that 1 billion would be just as likely as 1, and 475,000 would just be as likely as 475,001. That the modularity and the dispersion makes for the well-ordering and the well-foundedness, these three ways to look at least three laws of large numbers, which readers or listeners of this podcast may be able to recall from earlier discussions, or at least some few decades of that. So what that relates to this other definition of the exponential function is that it's its own antiderivative. And so it's kind of like its own derivative and its own antiderivative also, just this constant monotone, strictly increasing the points between 0 and 1. Via inspection, it is. And so it's a remarkable feature of mathematics, and there can't be any paradoxes, so somehow it's true. So that gets into the topology, as for example, as mentioned from Dana Scott and Jimmy Lawson. And then about it's kind of like my ignorance of that still I just built that so similarly, and about a finer topology, the finest topology, the own initial and final topology, the continuous topology. That's usual here. So looking at that then, it's good to reference Cotes and then because Euler has hundreds and hundreds of volumes basically, kind of like Leibniz, it has hundreds and hundreds of volumes to go through. And so the Cotes has many profound insights. With Cotes and Maclaurin and Hooke and these kinds of people, these were Newton's, as mentioned, giants and lions. And furthermore, each of them has a bunch of different stuff that you can find old wrapped as new in many accounts today. So yeah, this then is more about E. And then, for example, here's a section about the Bernoullis, a very famous family of mathematicians over several generations. The Bernoullis. My first inclination to relate to them is the Bernoulli trial, which is flipping a fair coin. And so infinitely many of those makes, for example, infinitely many fair coin tosses. But then if you consider a random number between 0 and 1 to be infinitely many binary digits, and so each time you flip a coin, it would be one of those, and so you could arrive at a random number at uniform random, as likely for any region within this extent by its length as any other of the given same length. And so when doing that, though, to accumulate a sample by random Bernoulli trials, every time you flip a coin, it starts a new sample. And so that at least helps explain why there can be as many rationals and irrationals, because if you sample an irrational, which is entirely unlikely that it never, can be any one of anything except that transcendental number, it's just as likely then that if there's one rational sampled, it's repeated that sample infinitely many times. So via Bernoulli trials, sampling a real number has it if it results a transcendental number, it's infinitely many transcendental numbers. But if it's an algebraic or rather rational number, it's one of those infinitely many times. So that way, for having somewhere between the Pythagorean where everything is rational and the Cantorians where everything transcendental, it can still have that. There's one where it's like it's half and half. I took this to the latest, greatest artificial intelligence the other day, and it's like, you know what I mean? That was amusing. So yeah, these books about mathematical constants get so profound. Then this is one about Euler's formula about the bridges or the Königsberg bridges, Königsberg problem, Knight's tours, Königsberg problem, graph theory, polygons and polyhedron. What relates the number of faces to edges to vertices. This is quite involved, and then the idea is about like work, time, and spatial inversion and turning that around for when it's still so involved yet not quite so simple, because that's interesting. Otherwise, it's like this is already given a fact. It's like, well, shut up and compute. The quantum mechanics is like somebody already did. What I'm looking for is stuff that can't be done but still must be done. This volubly computed bit. So anyways, these are some pretty good books, and each kind of exploring more thoroughly, and also helping provide some more of the surrounds of the history, so that people don't just like get the idea that, well, just one guy by himself invented or discovered all this stuff, discovering its by its structure and form, and inventing a way to say it. As well, there's so many aspects to go on to it, from like being introduced to the Pascal's triangle in 7th grade or something like that, and just saying, hey, notice how when you just add up the successive layers of this pyramidal hierarchy, the integers to the left and to the right, and it builds in the middle, all these terms that now it's got a path to it. And then taking that for Newton's method, Newton's like, oh, I'll just spin this to the right 90 degrees, and just call those zeros and ones and say that it must be a pattern that goes according to the geometry. So this makes one of these deductive models of the inductive account that otherwise then is written out as an inductive account for something like Newton's method, but is formally unjustified until it has some greater space to hold it up. That these are the kinds of things that help in terms of the many and various influences to help establish in the sense of the suspension of disbelief and the suspension of sense for belief in sense and this noumenological sense, that it's great, it's profound, and that will help. Excuse me. John Dos Passos presents the living thoughts of Tom Paine, P-A-I-N-E, Paine, an American founder, almost, you'd say. An army of principles will penetrate where an army of soldiers cannot. Tom Paine. So Dos Passos is really famous as an author. Here's some quotes from the back of this book. Abraham Lincoln says, "I never tire of reading Paine." Thomas A. Edison says, "We never had a sounder intelligence in this republic. He was the equal of Washington in making American liberty possible. Where Washington performed, Paine devised and wrote. The deeds of the one in the field were matched by the other with his pen. And consider Paine our greatest political thinker." Benjamin Franklin said, "Others can rule, many can fight, but only Thomas Paine can write for us the English tongue." And John Adams said, "Where freedom is, there is my home." Benjamin Franklin is reputed to have said to Tom Paine. Paine answered, "Where freedom is not, there is my home." This was the creed of Tom Paine, America's turbulent crusader for freedom and justice, the most hated and most revered man of the American Revolution. Without the pen of Paine, the sword of Washington would have been wielded in vain. So that's pretty high praise, or helping to indicate the deals that go on with that. It's been it's through a used bookstore as long ago as 1970. Still in pretty good shape here. The premier living thought series is designed to introduce the reader the essence of the great works from every age and nation, distilled and interpreted by kindred spirits of our day. So I'm not too familiar with reading Tom Paine yet, although I've heard of him. So it reminds me of the entire idea of U.S. history and having learned these things, and vis-a-vis the experience of things and the changes of things. "O ye that love mankind, ye that dare oppose not only the tyranny but the tyrant, stand forth. Every spot in the old world is overrun with oppression. Freedom hath been hunted round the globe. Asia and Africa have long expelled her. Europe regards her like a stranger, and have given her warning to depart, or receive the fugitive and preparing time and asylum for mankind. So this is that lots of people, when they came to America, so this would be in the era of the colonial times in America, meaning the American colonies were colonies of England. And so then there was the Indian frontier, and then there was all the different comminglings of peoples. And it was used to be that when we were learning history, it was like, well, Australia was a penal colony, and that's where they just sent people who were expelled, whereas America was Puritans, and they came here for freedom of religion and the New World. But then Georgia and Pennsylvania were just as well penal colonies, and it was just not unusual that according to population pressures in the old world, that people were sent to the New World. So that's just kind of the way of things. As it was not relayed, but is kind of a little bit better understood now. But that the American experiment in democracy began is by these great people like Jefferson and Washington, but and about as after the currents of the bondage, human bondage, and these kinds of things, vis-a-vis slavery or the indentured servitude. That aside, in a sense, because that's still, like, as for matters of colonialism, the idea of ending here was usually framed for taxation without representation. The idea of then what went into the thinking that people would buy into the American dream, which is still very well held. And even when the theater of it is to make it seem like it's such a wreck and shambles, that at the same time it's still considered to be much more so as of so enduring that that's just the latest spatter of paint on the wall, which time will wear off and down. And that it is there's not, it's not to be so like that the tearing down of the wall as for figures like Boris Yeltsin, and that is to be anyway involved, considered the same thing in the tearing down the hall, as it were, by the latest powers that would be. So when it comes to Tom Paine, then I imagine you'll find that anybody will have to say that if they're American in a sense, it's like, oh, of course, we got to agree with that, and then it's going to vary how that's going to be. I shall conclude these remarks with the following timely and well-intended hints. We ought to reflect that there are three different ways by which an independency may hereafter be effected, and that one of these three will one day or the other be the fate of America, videlicet. By the legal voice of the people in Congress, by a military, or by a mob. It may not always happen that our soldiers are citizens, and the multitude of body of reasonable men. Virtue, as I have already remarked, is not hereditary, neither is it perpetual. Shouldn't an independence be brought about by the first of these means, we have every opportunity, every encouragement before us to form the noblest, purest constitution on the face of the earth. And that's what happened. See, I found this book the other day. This is about the Mayans. So the Mayans were the historic peoples of Mesoamerica, as with regards to the Mayans and the Aztecs. And so, and this is about the Toltecs then, the ancient Toltecs. So there's the Aztecs, the Old Tecs, Toltecs, the Incans, and the Mayans. And these reflect for South America the idea of the culture that was there. And then before that culture kind of fell down. And it's kind of figured that they were higher as a culture at some point and then somehow descended at some point. Before what's generally considered as the old world's contact with what's called the New World, which has its own sort of stories and then possible forerunners that are usually left out. It's kind of like, well, Columbus was the first person to ever make it from east to west. It's like, okay. And then it's like, well, Leif Erikson was the first person to ever make it from east to west. It's like, well, and it's like, well, Arthur, when they went to the west to, they just went to America. Okay. And it's like, well, you know, before the Atlanteans, it's like there was actually an island chain, and there was kind of island hopping 10 or 15,000 years ago, and all this time. Well, it's like, well, yeah, and the peoples of all kinds of the races and the species of man and the kinds of Homo sapiens were all over the place and quite all together and all around of these things. You know, this is getting pretty far afield. It's like, well, you know, they have the same script, the Phoenicians and the Mayans, so if they can't have had the same alphabet without having the common origins, it just wouldn't make sense. That's pretty much the strongest sort of account. And so this is a philosophy, and it says the four agreements. Be impeccable with your word. Don't take anything personally. Don't make assumptions. Always do your best. And then the Toltec path to freedom is breaking old agreements on 93. So what does that say? Everyone talks about freedom. All around the world, different people, different races, different countries are fighting for freedom. But what is freedom? In America, we speak of living in a free country. But are we really free? Are we free to be who we really are? The answer is no, we are not free. True freedom has to do with the human spirit. It is the freedom to be who we really are. So this is as with regards to this suspension of disbelief and suspension of sense here. To be free, you have to be able to freely read. What stops us from being free? Who really stops us from being free? We have memories. If we see a child, we find a free human. Why is this human free? They're exploring the world. Why are we so different? Why are we not wild? It talks about law. It talks about struggles and the trials of life. The Toltecs as dream masters. Your life is the manifestation of your dream. It is an art. Now, as we suspend our disbelief or belief, and then the idea is still always kind of there, the anchor of belief in sense. That the back and forth is well protected. So it's just again about imagination and that being is part of intelligence for sure. And it's talking about the mind. So the mind. And it says these four agreements are about your freedom from what he denotes as the parasite. So hopefully this is not just new agey, but it's actually representative of kind of the ideas of what would have been part of this culture. In the tradition of the Toltec, a Nagual guides an individual to personal freedom. Don Miguel Ruiz, a Nagual from the Eagle Knight lineage, has dedicated his life to sharing the wisdom of the ancient Toltec. So this is a reminder of Carlos Castaneda and Don Juan, the Yaqui way of knowledge. I've never really followed that route, but I've read about it. It's not like who is that fellow Bateman or drinking the giant bowls of ayahuasca in the Pacific. Mind liberating accounts, or it's about like the ideas of the ancient culture of Turkey. So they had a voting an account, and one way they would vote would be they'd argue it and they'd debate it and then they'd vote, and then they overnight then they'd get entirely drunk and continue to argue it and debate it and vote, and then when they sobered up they would argue it and debate it and vote, because the idea is that the introduction of what would otherwise could be trapped in a mode helps establish the global minimum or global maximum as regards to perturbation and local minimum and local maximum. So such thing as the ideas of these swings and making changes and stuff like that can be even by sober people be a reviewed an account that they could be crazy. The things that are being attempted to be understood. So, and it's a free country, it could be that way. So this is just kind of an account of what my interpretation of that might be, because to each their own, and it is a free country. And that includes that people are free to be wrong, and it's not to be expected that otherwise everyone will be so. Well, there's a general expectation that people are good for their word, and people are good by default. And that thusly a lot of misunderstandings can be avoided. Well, at the same time, there's a certain tendered reserve or a guard always present of the mental variety, to help keep it from having to have one, up or a watch on everywhere else, which would be a big waste of time. Well, I went to the bookstore the other day. I went I went to the mall, and so this would be people's idea of, well, what is a bookstore? Is like, you mean the mall? And so I went to the giant bookstore, and this is the only book I could find. I looked around for a while, and I already have things like the classics I've read before, and there are some other ones that I perhaps find interesting, and I've already read some science fiction that I've read before, and there's some new stuff that I was like, well, what could they have come up with now? And then it's like, well, I don't need cookbooks or self-help or these kinds of business or biographies or the military history or albums or TVs or music or CDs or these kinds of things. What I arrived at this book. So this book's called Vector by Robin Arianrod, which is the name of apparently some Welsh. It's Welsh or something like that, or Gaelic or something. A surprising story of space-time and mathematical transformation. So this is a nice discovery of the vectors, as the vector is as kind of connected to a space. We have our theory of vector spaces and vector addition, and it's so great, and because it's just like numbers, you could just add them up, and then they don't really have division. They just have plain arithmetic of adding and subtracting. Then multiplication by a scalar, according to the usual theory of vector spaces, as with regards to the zero vector and multiplying by a scalar, and otherwise kind of being a field under that. And then the usual notion of the scalar product and inner and outer products, linear independence, the vector bases, make it so that you can say that something's so defined anywhere in that space by the given bases that, according to something like Descartes' theory of coordinates, makes for vector spaces and linear spaces. And then it's about linear independence, and then what's usually used to build up both the superposition for the quantum amplitudes, and then also the linear systems, the solutions to differential equations, and any of those being a putative, fitting the form of a solution of differential equations. So this book is about vector. And I started reading, and it really was pretty great, and it's getting us some examples. So I'm about 95 pages into it, talking about Stern and Gerlach and these kinds of things. Now, if this was from a couple years ago or so, do I think that it's possible that this was at least in part assisted by an assistant, like a writing assistant of the automated sort? Perhaps so. So talk about Hamilton and Grassmann and Hamilton and Grassmann, Euclidean geometry, Hamilton and Grassmann, then Gauss, and then getting to Bolyai and Lobachevsky and the non-Euclidean geometries, which here are just like, they got to be transforms and connected to Euclidean geometries. That's what it is. Talking about Lagrange and Laplace and Gauss, Poisson, Mary Somerville. It does help introduce people like Mary Somerville and Sophie Germain, which were not so much included, but are present in the accounts, and indeed in some cases, like Mary Somerville was quite influential. Laplacian, Maxwell, and then Faraday. So while Faraday didn't know much math, he certainly knew more than most about the physical nature of electromagnetism. This led him to develop a unique approach to the question of what was going on in the space between electric charges and magnets. He first got the idea when he noticed something that may well have fascinated you too if you took a school science class: the neat way that iron filings line up in loops around the poles of a bar magnet. So here that's the spiral waves and wave spirals. So it's considered, it's like, well, those are shells. And it's like, well, if you move it, they must have spin around somehow. If it would be possible to have like magnetic filings in a 3D space, so it's kind of just like in the media, and then if you just like raise and lower a bar magnet through the liquid in suspension, just kinds of things, to watch how the shells move through it, and as with regard to a die, that it would show the spiral nature of it. That would be pretty obvious. I'd never seen that before, but I would just so imagine that would be an experiment that would show that it's like. Reminding one of something like Courant and Robbins, or especially Courant, for Courant's books on analysis, and I have copies of Courant's integral and differential analysis here, and about the soap films, because the soap films automatically, naturally, given a wire structure and some soap film, automatically make a minima or maxima that they couldn't compute. And so for the catenary and other difficult sorts of problems with regards to the properties and the limits of something to hold and make a film, that's just another example of one of these things that where mathematics owes physics the proper mathematics to support what it really is. And so in the case of Faraday, Faraday was a physicist and had great physics and what that means. And about usually Heaviside it's referred to, because mathematics had arrived at what electricity should be according to the fluid model and these kinds of things, and the linear and the classical. And Heaviside showed them that they had to take a different sort of account. Einstein's success also quietly immortalized Ricci, so the RICCI. Ricci made the connection. He basically has kind of an annealing routine to help put these things together with the Ricci tensor. In the mathematical physics community, at least, critics such as Beltrami had complained that tensor analysis had no practical benefit compared with existing methods, but Einstein and Grossman had changed all that. As Ricci's dear friend Levi-Civita put it, the essential role of tensors in general relativity also became Ricci the just dispenser of glories, and his great contribution was officially recognized at last. So these people are mentioned here, particularly Levi-Civita and Ricci, and kind of Levi-Civita, because he's like, well, we got an absolute differential calculus somehow. And so he introduces things like the indefiniteness of the ds squared, or the infinitesimal, that sits in the Lorentzian, which is all that relativity can really say it is, meaning anything that lines up and makes for that being invariant is confirming Einstein's theory, which is really Lorentz's theory, which is really kind of Ricci's approach, that these are the kinds of things it is. Yeah, when you hear that Einstein's theory is being confirmed, it's like Einstein's theory can be confirmed at least 10 or 15 different ways. So it doesn't say that it's confirmed in all the ways, which is kind of the idea that it would be. I mentioned Struick, so the historian Struick. So there's definitely, when I intended to convey that some of the styling is after an editorial approach to this sort of work, might have been through something like the great smoother of the constant monotone mind of the giant hive mind of usual accounts of commodity AI things. There's still much great material here, and so it would trouble me to think that because something was sent through an editorial pass that then suddenly I thought and made suspect all the otherwise the content is from otherwise the author. That would trouble me a bit, because otherwise, I'd like to think that it was a little bit more personal than that. And then with regards to the editorial and the idea that somebody wrote that word, it's like I can kind of formalize and show that somebody didn't write that word, but just kind of didn't read it, or that it could be garbled in a sense. So Struick, and so it's talking about a Struick there. So then we have to get involved with other Struicks. Struick later became a historian of science, and there's an idea that this Struick is very long-lived, is the idea, and that Zeno, for example, is very long-lived, and that's unusual usually. Talking about Emmy Noether. So the idea of Emmy Noether, and especially her coterie students were very strong. But the Noether's principle and Noether's theorem, and making for the symmetry equals there being an invariance equals there being a conservation law. Has it here? There's this. Well, we got continuity law and flow and flux, and so there's a give and take, and so it's got to be continuity law instead of conservation law. And then the quasi-invariant for the measure, and the symmetry-flex instead of the symmetry breaking otherwise, because what that ends up being is it's a very fixed, firm classical account, but if it bends, it breaks. Whereas in an account of sum of potential, sum of histories of least action, least gradient, as it bends, it bends. So this is just going to show that there's this greater sort of account here of the A theory and the foundations briefly, but that are including otherwise these greatest centralizing principles while kind of supplanting and giving them grounds for justification themselves instead of just breaking them, and because they would have to be repaired right for the instance in the moment of these things. That's all usual. The likes of Arnold Sommerfeld and David Hilbert were appalled at the direction their country had taken. And he's talking about Eddington, some history. For mathematics, the whole world is a single country. It is a noble sentiment. It is true in the sense that international collaboration has always been important in the advancement of mathematics, which is now an international language. Yet at the same time, there's like all these attempts to sway the thing and wrap the old as new. For example, about mathematics or like, new math or these kinds of things. Or like after World War II and a bunch of the stuff, the Germans and the Japanese got absorbed into the Americans and the Soviets. And then what was to come of this? So like for the whole determinantal analysis and a bunch of stuff like out of geometry and some even algebraic geometry, then that was just tore all the way back down. But then out of that also is like, well, Bourbaki is like, I don't know whether Bourbaki is out of Vichy France or de Gaulle France. Like France is really bipolar in this kind of context. I mean, were they really like vive la resistance, or were they ha? I don't know. And so as far as that goes, it's just something to show that I don't necessarily trust the attachments. But finding a history of it helps a lot, because then it helps to make it so that one has a sense of belief in it, and a mathematical sense and a sensibility to then be able to approach these things. So yeah, I don't need much from Grothendieck or Langlans or anything like that. And I think they've just kind of gone far afield. Not now. This is beyond the ideas, the questions of priority and authorship and these kinds of things, and the history of it. Because as far as that is concerned, that is the mathematics. Because that's the formal development. That's the development. And if you're going to make something equi-interpretable, say the same thing about a different branch, it's a necessary thing to do. And so here it's kind of figured that there's an original analysis, at least to begin. So it's not going to matter, like a certain higher mathematics that's kind of separated itself from some of the criteria otherwise. But that's going to help, one hopes, to be able to have like a theory already when it comes to things like automated theorem provers too dense to read through, or higher mathematics whose fundamental theorem of inversion can't arrive until after the top when it's all too toppled, these kinds of things. So that just goes to show, for an opinion in mathematics, then this author is speaking to the ideas of the winds of change and these kinds of things, where the wind of change is a song, and the winds of change generally reflect hard times, though, instead. That it's in the things. Cartan, Elie Cartan, Ricci's tensor calculus, Elie Cartan. And that's the end. It mentions this, so then there's just a timeline. So the timeline kind of gives a linear development, because it's figured in mathematics to study that people would kind of have to be familiar with everything that came before, and when it happened, and in what order. But then it is reordered in many different ways. Talking about Thomas Harriot, though. Harriot is 1619. So in the time of like 1572 is Bombelli, and so that's complex numbers for you. And then Harriot comes with vectors, prefigures the idea of vectors, and uses the parallelogram rule correctly. So here the vectors is just whatever meets the parallelogram rule, much like Lorentzians is whatever makes the Laplacian and the Minkowskian, with the zero being for Levi-Civita, the indefinite ds squared. And it's all quite quadratic and partial in the second order. Yeah, and that's standard for sure. All right, so to the box then. Let's see what I find from the box. Theory and applications of electron tubes. So before there were transistors, there were tubes. So there's vacuum tubes and gas discharge tubes. So here's mentioned mostly the idea of the thyrototron, that the thyrotron is a gas discharge tube which allows power electronics to control electricity with much smaller amounts of electricity. So the gate voltage can throw open and closed gate of otherwise current that would be arbitrarily larger than the gate voltage itself. And whereas, well, it's arbitrarily high efficiency. And then the thyrototron is just the idea is like, well, just point a direct current electrode at a ring magnet. It will make an arc and it will go around in a circle to implement rotatory motion. And that, instead of like a bank of transistor or MOSFET switches, the efficiency of which will always be losing in heat and burn out. The idea of the thyrototron is basically a high current device, and it's a solid state device in effect, although with regards to that the arc and the current is plasma, another state of matter in that sense, or the dynamic state of the events, that the thyrototron is something after something like this book, which will explain, as of a time, Reich's book. It's by a fellow named Herbert J. From 1944 out of Harvard University, from the University of Illinois. Copyright 1939 and 1944. The Theory and Applications of Electron Tubes. This is as much a relevant work for power electronics as it would be in various ideas of application as to digital electronics. It's very analog, thus in a sense, but affecting to describe mechanisms that can never be implemented in silicon because it would just melt. This is to be consulted and considered quite a bit more. High energy electron scattering. Russell A. Bonham and Manfred Fink in the ACS Monograph 169 have this book called High Energy Electron Scattering. So electron scattering gets involved in that there's light, and so then the idea of light and electricity and quanta is that, well, they're each quanta, and so they're corpuscular and they're particle-like, and they have the frequency wavelength, defining them as for the wave number, wave velocity as waves, but they're particles, light and electrons. So the rays of light and beams are current of electrons. So beams and current are two different things, and when electrons are kind of aggravated, I guess that's not the right word. Stimulated to be emitted as a beam of electrons, then they don't behave exactly like light, because optical light is special and is free and the fixed and metered, whereas electrons are yet corpuscular, whereas light is not in some setting of the sense. That they relate, though, in terms of the energy, according to that, well, a given amount of energy is a given amount of energy, and it just happens to be so defined by the wavelength, and the frequency and the wavelength. This is according to the particle, because that just represents change, a model of change in an open system as a wave, as energy. It's just the way it is. So electrons are different, though, than light, and so an electron beam is like a different. It's like a spalating and this kind of stuff compared to the ray of light, which may be ablating, say, is like by a laser. That electrons and photons are different, but they much of their mathematics, so their motion and their interchange is the same. Talking about the Born series, Born amplitudes. So this is probably after the Born law, which is just, it's classical in a sense. Borshal and partial wave intensities for Mercury. Phase of the scattered amplitude for Born and partial wave calculation. So waves and partial waves are the focus of this work. The scattered amplitude. This is about scattering and tunneling. Is how the beams, the spalations scatter. That the Huygens principle, waves make waves, and these kinds of things. Again, this is something to follow up later. Points to something like Green's function. getting reasons why the diffraction energies may be systematically in error. So that's the key thing about after refraction and diffraction, that light and electrical are different. So the studies on page 140 says, and that's kind of why I wanted to look at this for something like this. The studies we have reviewed here barely scratch the surface of the possibilities for measurement in this area. It is hoped that the debate, in quotes, presented in this and other chapters of this book will point out to chemists the many kinds of chemically interesting data available from electron scattering experiments. In the concluding section of this chapter, we will present some of the possible reasons why the diffraction energies may be systematically in error. Modified Born, the second Born approximation. So getting up into the limits of the methods, which are partial, and finding other partial methods to help patch together the missing next components. In 4.32, we have clearly an interference between an electron scattered by atom I and an electron scattered elastically twice within atom J. So this gets into what's considered the interfaces of continuous and discrete with regards to halving spaces and doubling spaces. And then with regards to energy, to help identify energies, wave packets, they're usually put for the solitons and instantons. Because it's got to be a thing. Yeah. And so as a particle, it's already been given this reduction to establish kind of how it is so, and that adds up in the large. But then to help explain again why, when it's a different state of matter, the plasma, after thermionic emission, the electron beam, then this is why something like that book is relevant, because everything would be after that. E.G. Richardson, Relaxation Spectrometry, North Holland Publishing Company. Aeronautics Collection. Both in academic circles and in industry, much interest is shown nowadays in those molecular properties of solids which are grouped under the terms elastic modulus and internal friction, particularly experimental studies of this type have enhanced our knowledge of the structure of metals and of high polymers. Relaxation spectroscopy. So this is helping show ways to relate relaxation and creep. It's sometimes called the elastic. So the viscoelastic and elastic. So this was somewhere between the book on spectroscopy that was read up the other day and the books on elasticity theory. And the fact that according to something like Newton's laws, it's like, well, everything is just perfect inelastic collisions. It's like, well, yeah, in reality, nothing is. So then this gets into then the continuity conditions, continuity equations, and these sorts of things. Handbook of High Vacuum Engineering by H.A. Steinherz, Steinherz. Manager in Engineering and Development of Departments, NRC Equipment Corporation, Newton Highlands, Massachusetts, Reinhold Publishing Corporation. So it's kind of like, Aristotle says, it's like there's no such thing as a vacuum. And it's like, well, making a vacuum is hard, because by the time you get it up to hold hydrogen out, it actually, pretty much every material will let hydrogen in. So talking about ultrasonic technologies, after things like the pump and the notions of usually mechanical pumps, then it gets into ultrasonic treatments, high vacuum technology, completely covering. Oh, that's the next book, is ultrasonic technology. From vacuum freeze dehydration to circuit miniaturization and shrinky dinks and these kinds of things. Ooh, kind of like the Z-pinch. For a while, it was like, what does the largest capacitor applied application energy in the world do? It's like, well, they got Z-pinch. It applies a magnetic field at a moment. General purpose. Design calculations versus performance. Trade-offs. Leak detectors. Photomultiplier ion gauged. Pulse type ionization gauges, radioactive ionization gauge for wind tunnels. So accelerometers, measures, inverted magnetron pumps, oil ejector pumps, mercury diffusion pumps. Ultimate pressure. The ultimate pressure of a diffusion pump is defined as the limiting pressure approaching the vacuum system after sufficient pumping time to establish that further reductions of pressure will be negligible. Term is used synonymously with blank off pressure and base pressure. So there's ideals and then the practical, and so this helps explain all the ideals and the practical. Well, time has come to the hour. So those loose books kind of left off from some of the other books. Bombers of the 20th Century, and we won't be needing that for a while. What's this now? Cosmic Horizons. This is a great little book. The Portable Stanford, I guess, is this series. Stanford Alumni Association. Robert V. Wagoner and Donald W. Goldsmith, Cosmic Horizons. So, as you might imagine, there's some astronomers. Gas and degeneracy. Physicists call this forcing of additional fermions into states of progressively higher energy a condition of degeneracy. And so that helps go, that's the usual term with the degenerate, the quasi, and the pseudo, with regards to these points and the continuous and discrete, about quasi-invariant, symmetry-flex, and continuity law. That being the laws of physics now. Well, all right, you gentle readers, I shall hope you had a great day today, and that things are well. It's cooler here as the weather turns, and it's entering the winter soon, and that's refreshing. So, good luck and keep on reading.